All right, hydroelectric power. This has been an energy resource that has been used for many, many years, though not necessarily to produce electricity. And, you know, an energy resource does not have to produce electricity. Obviously, we use it for transportation and heat and other kinds of things. The mills. Has anybody ever been to the De Leon Springs, the pancake place there? It's got a little mill paddle wheel thing on the side. Yeah, it's a real good place to go. Get that for me, please. So yeah, that is an example of what nowadays they would call micro hydropower, because you're utilizing the energy of a flowing medium, in this case water, and it is, but you're not using the whole river. Okay. So, like I said, it's been something that's been used for quite some time. Mills, as they call them, have been around for a while. It does use the current, and gravity technically is the technical term. I'm going to give you both a point for that, but the official answer is gravity. In order to fully utilize the power of a river, of course, you've got to get all of the river water to go to turn your turbine. Now, you remember the thing we did before where we had steam being produced, turning a turbine that then turned a generator? Well, this is not a heat-based power plant, so you're utilizing the movement of something to turn a turbine. In this case, of course, the movement of water. And therefore, to get the whole power of a river behind it, you got to channel that water. In order to do that, you have to build a dam. Okay. So that's what you do whenever you make a hydroelectric power plant, and the water is channeled through or put through these, they call them, gosh, I can't remember what they're called, silcox, I believe, but they have a channel that they go through, and that pushes the turbines, and that they spin, of course, and then generate electricity that way. Very good as far as pollution goes. No pollution produced by that. No, you're not burning anything. You don't have any toxic substances you have to worry about, like with nuclear energy. So those are the good environmental sides of it. The bad environmental sides of it is right here. Is you have to build a dam. This is a water diversion project. We talked a little bit about the problems that dams can cause. We did, I think, a free response question that talking about the things that they do. Completely changing the habitat of the river whenever you put a dam up, because you're going to raise the water level behind the dam and therefore flood that whole area. So you go from being a river / wetland area to basically a lake, or reservoir is usually what they call it because it's artificial. So that's habitat disruption. Downstream, you're going to completely drain that. It's going to become dry. A lot of times dams have been used, as a matter of fact, to dry out areas so they could use it for farming and stuff, because the soil that's left behind is often very rich. So that's going to be habitat destruction and alteration on that end of it, on the both upstream and downstream. You also are interrupting a very important function of rivers, which is redistribution of nutrients in the form of sediments. And hopefully you remember from the rock cycle the fact that that erosion and the wearing down of the mountains and stuff like that brings those minerals and things down and spreads them out in the valley, and that's an important way to keep the soil replenished. And of course, a dam is going to stop that from happening. So you can see things like that. Aswan Dam in Egypt, as a matter of fact, was built to supply water for people, because for the reservoir, but they end up damaging crops because the nutrients were interrupted on the downstream side of it. And so that's a problem that a dam produces. And then also spawning species of fish. You may know that many fish, in particular salmon, they are born upstream in the mountains. They make their way down into the ocean, they live in the ocean for a while, and then they come back upstream and start the whole process again, although they die while they're up there, and their babies go through and redo the whole process. That's a problem if you've got a 100-foot dam in the way. Now, you may know that salmon can jump, but we're talking 8 feet maybe at the most. They're not going to jump over a dam. So that's been shown to have major impact. The Atlantic salmon populations in the North Atlantic have been severely impacted by the series of dams and everything that have gone on in Canada, in St. James region of a lot of hydroelectric power projects have gone up there, and that's had a big problem with those. There's a solution for that, which I'll show you in a minute. And then finally, because you're no longer a flowing river before the dam, you're a lake. Lakes are less turbulent, therefore lower in the amount of oxygen they have in the water. So a lot of times that will cause fish to die because of those low oxygen levels, because the water is not turbulent anymore, and those fish are adapted to that. And therefore that also is a problem.